Hi, Software Engineering Lecture 3.2. Today lecture is about software development life cycle and we will discuss iterative waterfall model. And these are adopted from the latest software engineering books. What is iterative waterfall model? Definition of iterative waterfall model. The iterative waterfall model is a software development approach that combines elements of both the traditional waterfall model and iterative methodologies. Brief overview of model structure. It involves breaking down the project into a smaller iteration, each following the phase of the waterfall model. For example, requirements, design, implementation, testing, and deployment, but allowing for the feedback and adjustment between iteration. Importance of iteration in the development process. It provides opportunities for continuous improvement and adaptation to changing requirements, enhancing overall project efficiency. Feedback path. In the classical waterfall model, there are no feedback paths. So there is no mechanism for error correction. But in the iterative waterfall model, feedback path from one phase to its preceding phase allows correcting the errors that are committed, and these changes are reflected in the later phases. Phases of iterative models: requirement gathering and analysis. This phase focuses on collecting and analyzing client requirements to ensure they align with project goals and budget. Analysis assess feasibility and potential impact on the project scopes. Design phase. The design phase involves creating comprehensive design specification using various diagrams to visualize software structure and functionality. Implementation phase. During implementation, specification and transformed into code using selected programming languages. This phase focuses on actual software development based on design specification. Phases of iteration model. Testing phase. Testing commences after coding, covering functionality, performance, and reliability using varied approaches like white box, black box, and gray box testing. Deployment phase. Deployment involves integrating the software into operational environment. Following completion of each development phase, ensuring readiness for end user utilization. Review phase. The review phase entails assessing product behavior and validity post-deployment, with iterative refinement made based on feedback to enhance performance and functionality. Maintenance phase involves resolving post-deployment issues, debugging existing code, and incorporating feature enhancement to optimize software performance and user experience. Incremental developments. Each increment delivers a segment of system functionality, allowing for regular feedback and refinement. Phases I have already discussed: planning, design, implementation, testing, development in the previous slides. Feedback driven. Feedback gathered at the end of each iteration helps identify areas for improvement and guide future development process. Incorporating feedback into subsequent iteration enhance the product's usability, functionality, and overall quality. Flexibility and adaptability. It allows teams to respond effectively to evolving needs, market trends, and technological advancement. This adaptability ensures that the software remains relevant and responsive to evolving business needs and user preferences. Risk management. Risks are identified early in the development process and addressed in the subsequent iteration to minimize their impact. This approach reduces the likelihood of project delays, cost overruns, and quality issues, enhancing project success and stakeholder satisfaction. Continuous improvement. Regular reflection, evaluation, and adoption enable teams to identify areas for improvement and implement corrective actions. Lessons learned are applied to future iteration, driving ongoing improvement and innovation. Suitable for large products. Its adaptive nature allows teams to handle uncertainty and accommodate changing needs over time. Requirements evolve gradually through iterative cycles, ensuring alignment with evolving business goals and user needs. Enhance collaboration. Open communication channels for facilitate collaboration among them members, stakeholders, and end users. This promotes participation at every stage of the development lifecycle, fostering alignment of project goals and stakeholder expectation. Phased delivery. Each iteration introduces new feature or enhancement, allowing for a gradual expansion of product capabilities. Stakeholders can provide feedback early in the process, enabling teams to make adjustments as needed to meet evolving requirements and preferences. Importance of the iterative models. Enhance flexibility. Flexibility is a crucial in today's dynamic business environment where requirements and priorities can change rapidly. The iterative model allows teams to impact on these changes effectively, ensuring that the final product meets stakeholders' needs. Continuous improvement. Continuous improvement is essential for delivering high quality software that meets user expectations. The iterative models enable teams to learn from each iteration, refine their process, and enhance the product functionality and usability over time. Importance of iterative models. Early delivery of values. Early delivery of value is key to building customer trust and ensuring project success. By delivering valuable functionality, incremental teams can demonstrate progress, validate assumptions, and course correct as needed, leading to a more successful outcome. Risk mitigation. Risk mitigation is essential for project success, particularly in complex software development products. The iterative model enables teams to identify and address risk proactively, reducing the likelihood of project delays, budget overruns, and quality issues. Increase stakeholders' engagement. Stakeholder engagement is a critical for building software that meets user needs and delivers business values. The iterative model ensures that stakeholders are actively involved throughout the development process, leading to a more successful outcome and greater satisfaction. Adaptability to change. Adaptability to change is essential for staying competitive and meeting evolving business needs. The iterative model enables teams to respond quickly to change the requirement, technologies, and market conditions, ensuring that the final product remains relevant and valuable. Improved product quality. Product quality is a paramount in software development. The iterative model emphasizes testing and validation throughout the development process, leading to a more stable, reliable, and robust product that meets user expectations. Cost and time saving. Cost and time saving are significant benefits of the iterative model. By delivering working software increment early and frequently, teams can minimize rework and maximize efficiency, leading to a faster time to market and lower development cost. Feedback path. The feedback path is iterative waterfall model enables communication and feedback loop between project phase, allowing for adjustment and improvement based on a feedback received. This differs from the traditional waterfall model, where feedback is limited and changes are difficult to incorporate once a phase is completed. The feedback path facilitates error correction, continuous improvement, and better alignment with stakeholder expectation throughout the development process. Simplicity and parallel development. The iterative waterfall model is a relatively simple to understand and implement compared to more complex development methodologies, making it accessible to teams with the varying level of experience. It allows for parallel development activities where different parts of the product can be worked on simultaneously by separate teams or individuals, enhancing overall efficiency and reducing project duration. Adaptability and flexibility. The iterative waterfall model is highly adaptable to changing product requirement as adjustment can be made in subsequent iteration based on evolving stakeholder needs and feedback received. It offers flexibility in response to feedback and allows for iterative improvement throughout the development lifecycle, ensuring that the final product meets stakeholder expectation and quality standards. Testing and debugging. Testing and debugging are integral part of each iteration in the iterative waterfall model, ensuring that issues are identified and addressed early in the development process. Testing during smaller iteration allows for more focused testing efforts, making it easier to identify and resolve issues efficiently before they escalate. Collaboration and stakeholders involvement. The iterative waterfall model promotes collaboration between business owners and the development teams, ensuring alignment with the business objective and user needs. Stakeholders are actively involved throughout each stage of the process, providing valuable feedback and insight that contribute to the success of the project. Risk management. The iterative waterfall model facilitates early identification and mitigation of risk through continuous monitoring and evaluation of project progress. Risks are addressed incrementally in each iteration, allowing the proactive risk management and reducing the likelihood of costly error or setback later in the development process. Improved quality and customer satisfaction. The iterative waterfall model emphasizes quality assurance throughout the development process with regular testing and feedback loops to identify and address issues. This focus on quality results in a higher quality and product and improved customer satisfaction as the final product better meets the need and expectation of stakeholders. Phases, adopt approaches and predictable outcomes. The iterative waterfall model follow a phased approach to development with each iteration building upon the previous one to achieve incremental progress. This phase approach allows for more predictable outcome and greater control over the development process, ensuring that the project stay on track and within the budget. A cost-effective and time to market. The iterative waterfall model is cost-effective as it allows for changes and adjustment to be made throughout the development process without incurring significant and additional cost. Additionally, the incremental progress achieved through iterative development leads to faster time to market as valuable functionality is delivered in small increments rather than waiting for a complete product to be developed. Disadvantages of iterative waterfall model. More resource requirement. Implementing the iterative waterfall model may require additional resources including time, manpower and budget. Difficulty in handling change request. All requirements must be clearly defined before development begins, making it challenging to incorporate change requests that arise after the development phase are started. Lack of support from intermediate delivery. The project must be fully completed before it is delivered to the customer, resulting in longer wait time for the delivery of final product. Limited risk handling mechanism. The model lack of formal mechanism for handling project risk, leaving the project susceptible to various types of risk without adequate mitigation strategies. Incompatibility with small projects. The iterative waterfall model may not be suitable for smaller projects as it is structure and requirement may overly complex for such endeavors. Potential for design changes due to imperfect requirement. Imperfect or unclear requirement may lead to frequent design changes, causing delays in efficiency in the development process. Budget overruns due to requirement changes. Changes in requirement during the development phase can lead to budget overruns as additional resources may be required to accommodate these changes. Uncertainty in project completion date. Changing requirement can result in uncertainty regarding the project's completion date, making it difficult to establish a definite timeline for project delivery. Limited customer interaction. Customer interactions are limited to the beginning and the end of the project, potentially leading to misunderstanding or discrepancies between the final product and customer's actual requirement. When to use iterative waterfall models? The iterative waterfall model is the best suited for projects that require a structured approaches to a software development while still allowing for some flexibility and adaptability to changes. Here are the situations in which it is appropriate to use the iterative waterfall model. Well-defined requirements. When project requirements are relatively stable and well-defined upfront, making it possible to plan the entire development process in advance. Sequential development. When the project can be logically divided into sequential phases, each building upon the work completed in the previous phase. Limited customer involvement. When customer involvement is a minimal or limited to specific stages of the project, such as requirement gathering and final product delivery. Clear project scope. When the project scope is clear and there is a little likelihood of significant changes or addition to requirement during the development process. Structured approach. When there is a need for a structured and systematic approach to software development with early defined phases and deliverables. Risk management. When there is a need for a formal risk management process to identify and address potential risk early in the development lifecycle. Regulatory compliance. When regulatory requirements or industry standards dictate a sequential and well-documented approach to a software development. Large-scale project. When working on a large-scale projects with complex requirement, where a phased approach to development helps managing complexity and maintain project control. Resource availability. When resources such as skilled personnel and budget are limited and there is a need to plan and allocate resources efficiently throughout the project. Project constraint. When there are constraints such as time, budget, or technology limitation that require a more structured and predictable approach to development. Application of iterative waterfall model. Engineering development teams. Engineering teams frequently employ the iterative approach to develop new features and address problems. They create multiple iterations of solution, test them with user, evaluate their performance and iterative until satisfactory results are achieved. Electronics industry. Iterative development is a prevalent in the electronics industry, driving product evaluation. Example include the continuous improvement of mobile phones, speaker, and refrigerator based on customer feedback. Digital marketing teams. Digital marketing teams utilize iterative testing for advertising strategies to enhance engagement. They analyze the requirement, design attractive ads, gather feedback, and it relatively refine their marketing tactic based on results. Cross-industry adoption. The iterative model is versatile and adaptability, making it widely adopted across industries such as electronics, marketing, and sales. Its features including parallel development, multiple testing, and early risk identification contribute to its widespread use. Iterative approach cost. If the software is development using uh, iterative approach, there is a no hard line uh, between specification and design and developments. Specification costs are reduced because only a high-level specification is produced before development in this approach. Specification, design, implementation, integration, and testing can carried out in a parallel within a development activities. Some models and thanks for watching. If you enjoy the content, consider subscribing, hitting the like button, leaving a comments and sharing it with others. Thank you.